welcome. Today we're going to be looking at circle theorems as part of the additional topics in math, which is mainly geometry and trigonometry. As always, we're going to be looking at 5 questions. We're going to explain them, and we're going to look at the intricacies of this topic to help you ace the SAT math portion. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on our first question. The sector of a circle shown at left has center Z. The length of the chord XY is 24. The distance from Z to the chord XY is 5, shown by WZ. Finally, WZ is perpendicular to XY and bisects XY at W. What is the radius R of the circle? Well, we know that WZ bisects XY at W. That means that this portion right here is going to be 12. And since we have a right angle right here, we know that by the Pythagorean theorem we have 12 and 5, so this is going to be R, or it's going to be 13, which is R. So we have 13 right here, so R is equivalent to 13, and that's our answer. Let's move on to the next question. All right. Next question then is metal wedge to the use of corner brace has the shape of a quarter circle shown at left. Angle ACB is a right angle, and the length of chord AB is 2 centimeters. Well, what is the length of the arc ADB? All right. Well, since this is a quarter circle, this is going to be a quarter of the circumference. And since we know that AC equals CD, since they're both radii, and this is going to be a 45, 45, 90-degree triangle. So that this side length is square root of 2. This side length is also square root of 2. Because this is 2. So the radius is square root of 2. The diameter is 2 square root of 2. And the circumference is 2 pi square root of 2. Right, so that is the circumference. A fourth of that is going to be over 4. Is just going to be 2 pi. That's our answer. Let's continue. All right, next question. Here it is. The circle shown at left has center at point O. Chord AC is perpendicular to radius OD and intersects OD at point B. Line segment OB has length 8, and line segment BD has length 9. What is the length of chord AC? Well, let's see what we can do with this. So this is a radius right here. And this is another radius. Now, what is the radius? Well, this is the radius. OD is the radius. And we're told that this is 8 and that's 9. So the radius is just 17. So this is 17. And this is 17. And OB is 8. Well, do we have a Pythagorean triple for 8 and 17? We do. It's 8, 15, and 17. You don't have to memorize this, but you do have to remember how to drive this because this is a non-calculator question, so it would be good to know this or to have it in your memory somewhere. 8, 15, 17. So then this AB right here is going to be 15. AB is half of AC, so since AB is 15, AC is going to be 30, and our answer is B, 30. Let's move on to the next question. All right, and here we are. In the figure at left, point C is the center of the circle. Line segment CD is perpendicular to line segment AB and bisects AB at point E. If AB equals CD equals 10, what is the length of CE? Well, let's know a couple things, right? We can draw some lines here. So, draw some lines here. Right. Now we know that CD is 10 and AB is 10. And since E bisects AB, then we know that AE is 5. So we know that this radius here is 10, right? Then we know that this CE right here is going to be 5 times the square root of 3 by the Pythagorean theorem, or answer choice D. So that's our answer. Let's continue on. All right. Our quest is sector of a circle shown as left has its center at point A. The length of AC is 8. Line segments AD and BC are perpendicular and intersect at point E such that DE has length 1. What is the length of chord BC? All right. So this is 8, and this is the radius. So this AD is also going to be 8. And since ED is 1, then AE is 7. So by the Pythagorean theorem, we have 8 and 7. 8 squared minus 7 squared is going to be 15. So CE is going to be the square root of 15. And since CE equals EB, since E bisects CB, and we're trying to find BC or CB, we double it, and we get 2 square root of 15 for answer choice A. And that's our answer. All right, as you can see, the circle theorem was mainly focusing on the Pythagorean theorem. It was mainly just using the geometry skills we already know of bisecting, of right angles due to the Pythagorean theorem. That's all you need to know for circle theorems, and I'll see you next time.